If you've ever searched for gold, you've probably been taught to look for obvious signs. Quartz veins, iron staining, exposed bedrock, bright colors in the rock. But here's the problem. Most of the ground that actually holds gold doesn't announce itself. It doesn't stand out. It doesn't look exciting. And that's why it gets, music, ignored. Today, I want to show you why the quiet geological clues matter far more than the obvious ones and how experienced people miss gold simply because they're trained to look for the music, wrong kind of signal. This isn't about spotting something flashy. It's about understanding what nature does when it stops drawing attention. By the end of this video, you'll know what to notice when nothing looks special and why those are often the places that matter most. Most people enter gold country already searching for contrast. They expect something to jump out at them. A sharp color change, a vein cutting through rock, a dramatic exposure that looks different from everything around it. That expectation shapes every decision they make. If nothing stands out, they move on. What they don't realize is that gold is rarely found because something, music, looks different. Gold is found because something behaved differently, music, often quietly over long periods of time. Nature doesn't always mark those moments clearly. In fact, the most important geological clues are often the ones that blend in. Quiet ground doesn't mean inactive, music, ground. It often means settled ground. And settlement, music, is where gold belongs. One of the biggest mistakes people make is assuming that obvious signs are reliable indicators of value. Quartz is obvious. Iron staining, music, is obvious. Broken rock is obvious. But obvious does not mean important. Those features are common. They exist in countless places where no gold ever settled. Quiet, music, clues, on the other hand, are rare, not because they don't exist, but because they're easy to overlook. They don't shout. They require interpretation. And interpretation is where most people stop paying attention. When experienced prospectors miss music, gold, it's rarely because they failed to notice something dramatic. It's because they dismiss something subtle. They looked at ground that appeared uniform and decided nothing happened there. But geology doesn't work in dramatic moments alone. It works through small changes, music, repeated over time. A slight reduction in slope, a minor widening of a channel, music, a gradual change in sediment size. These are not exciting to look at, but they are decisive. Gold responds to those changes far more reliably than it responds to visual drama. Another reason quiet clues matter more is because gold doesn't behave like most materials. Music, it doesn't move easily. It doesn't float. It doesn't, music, spread evenly. Once gold finds a place where energy drops enough for music, it to settle, it tends to stay there, even when everything else continues moving. That creates locations that look, music, completely ordinary on the surface, but have a very specific internal history. Most people never learn to read that history. They're taught to hunt for features, not processes. They're trained to identify what looks like gold country, not what acted like gold country. Music, that difference is critical. Quiet clues are not things you spot instantly. They are things you notice when you stop, music, rushing to judge. One of the most powerful quiet clues is consistency. Not visual consistency but behavioral consistency. When material size remains similar over distance. When gravels are evenly packed. When layers repeat without interruption. This kind of ground looks boring. People assume nothing happened there. But consistency often indicates, music, a long-term stability. And long-term stability allows heavy material to accumulate. The river never announces gold. It never sparkles on the surface or marks its location with anything dramatic. Gold is revealed only to those who understand how rivers speak quietly through stone. Long before metal detectors, long before pans and sloughs, rivers were already sorting, signaling, and pointing. The mistake most people make is, music, believing gold must be seen to be found. In reality, gold is read. When a river, music, carries gold, it leaves behind a language written in rock shape, texture, weight, music, and placement. The first mistake beginners make is looking for yellow. The second mistake experts, music, make is looking for obvious signs. The river does not reward either. It rewards, music, patience and interpretation. Upstream movement is never random. Every stone in a river has been judged by water. Light, music, stones are pushed farther. Fragile stones are broken. Flat stones travel differently than rounded ones. Dense material resists motion. Gold being both dense and malleable behaves in a way no other natural material does. It does not roll like quartz. It does not skip like basalt. It sinks, folds, and locks itself into positions, music, where water loses power. Before gold ever settles, the river must first prepare the music ground. This preparation is visible long before gold appears. River rocks that look out of place are never accidents. When you see stones that seem heavier than they should be, darker than the surrounding material, smoother on one side and rough on the other, the river is telling you something important. These stones did not arrive together. They were selected. Reading river rocks begins, music, with understanding energy. Rivers do not move evenly. They surge, slow, twist, and collapse in power, music, repeatedly along their course. Each change in energy leaves a signature. Where the river slows abruptly, it drops its heaviest burden first. Gold does not travel until the river is violent. When that violence fades, gold stops immediately. If the rocks, music, in a stretch of river suddenly become larger, denser, and more tightly, music, packed, the river has recently lost strength there. This loss of strength often occurs just downstream of a narrowing channel beneath a bend or after a sudden drop. But the most telling sign is upstream. When you see river rocks that appear unusually compacted, flattened into the riverbed as if pressed downward, music, rather than scattered, it indicates repeated high-energy events followed by calm. These conditions are ideal for gold accumulation upstream. The river slammed material forward, then relaxed. Gold, unable to escape once settled, stayed behind while lighter stones continued. Shape matters as much as size. Rounded stones indicate long travel. Angular stones indicate, music, short movement from a nearby source. When you find a mix, rounded river stones alongside sharp-edge fragments, the river has recently cut into fresh material upstream. Gold sources are, music, Ne. Far from freshly broken stone. Color is another quiet clue. Darker river rocks often carry higher iron content. Music, iron behaves similarly to gold in moving water, though far less, music, dense. When iron-rich stones concentrate, gold often concentrates nearby or upstream. Black sands are not a sign of gold themselves. They are a sign that the river is capable of holding gold. But the most overlooked clue is consistency. When river rocks suddenly become uniform in size and shape over a stretch, it means the river has found an equilibrium point. Everything lighter has moved on. Everything heavier has stayed. These zones act as filters. Gold that enters them rarely escapes. The river does not place gold randomly along these zones. It places it, music, where turbulence collapses, behind embedded boulders, at the inside edge of bends where flow slows but does not stop in cracks that run perpendicular to the current, not parallel. Gold always moves downward and inward, never outward. Upstream of these zones lies the source behavior. Rivers do not carry gold far, music, unless forced. If you can identify where the river first begins to show heavy material behavior, the gold is almost always above that point, not below it. This is the mistake that costs experienced prospectors years. They work where gold already settled, music, instead of asking why it stopped there. When river rocks begin, music, to show polish on only one face, the current has been consistent from a single direction for long, music, periods. Gold traveling in such a current settles in layers, not pockets. These layered deposits are upstream indicators. They tell you the river has been stable long enough for gold to organize itself. In the world of gold recovery, some methods are so overlooked, so simple that they almost sound unbelievable. Today, we journey into one of the most natural processes of all. Recovering gold using nothing more than boiling and cooling. No acids, no toxic chemicals, no heavy industrial equipment, just fire, water, time, and patience. But as easy as it sounds, this process hides secrets that only reveal themselves step by step. If you miss one stage, the gold remains locked, concealed in the rock and sand, mocking your efforts. Music, but if you follow carefully, what begins as dull material could transform before your eyes into shining fragments of treasure. Imagine standing by a riverbed, music, where quartz veins have shattered and released their contents into the sand. You scoop up a handful and hidden within that dirt lies the ancient legacy of molten earth. The challenge is unlocking it. Boiling and cooling may seem too gentle to extract, music, such a stubborn metal, but when done correctly, it can coax the gold to separate itself naturally. Music, and so the process begins. First comes collection. Not all material responds to this technique. You must start with ore, music, that carries free-milling gold or fine particles mixed with quartz, sulfides, or black sands. The sharp eye picks samples that, music, sparkle faintly under sunlight. Tiny flecks of metallic brightness or streaks of quartz threaded with iron staining. Each handful is a gamble. But within the right stones lies the reward. Music, now preparation. Rocks and sands must be reduced. Crushing is essential. Without acids or chemicals, you rely on heat and mechanical breakdown. The hammer, the mortar, the grinding stone. These become your tools. The ore is pounded into smaller fragments and then into dust fine enough that gold can be released during the boiling cycle. With every music you strike, the grains carry with them the story of mountains formed millions of years ago. Once the material is ready, the water is, music, brought to life. A fire is lit and a pot of water set to boil. Here lies the simplicity. Water, the universal solvent, when pushed to its limits of heat, can reveal surprising properties. As the ore is introduced into the rolling boil, the fine particles scatter, suspended in turbulence. Gold being dense begins, music, to behave differently than lighter minerals. At first, it seems chaotic. Clouds of dust, rising, music, bubbles, fragments colliding. But patience reveals order. The lightest silicates in sand stay aloft carried by the motion of boiling water. Tiny iron oxides may remain suspended discoloring the water with rusty tones. But the gold does not drift. It sinks resilient enduring the chaos until it settles at the bottom. Then comes the waiting. The boiling continues and with it the separation sharpens. This is not a quick trick. It is a gradual purification. The repeated cycles of rising bubbles and swirling currents work like nature's own SLES, shifting lighter materials upward and forcing heavies downward. If you scoop prematurely, the results vanish. But if you trust the method, the precious metal begins to stand apart. And when the boiling ceases, the next phase begins, cooling. It is during cooling that the most dramatic transformation can occur. As water slowly surrenders its heat, convection currents calm and particles find their final resting place. The lighter minerals drift toward the top or remain in suspension while dense fragments, including gold, form a concentrated layer below. The once chaotic mixture grows still like a hidden message revealed only when the noise fades. Cooling can take minutes or hours depending on the volume. Some practitioners accelerate it with cold stones or by pouring into secondary containers, creating thermal shocks that drive further separation. Imagine dipping a glowing hot stone into icy water. The cracking, the release, the sudden currents. In that turbulence, stubborn particles shake free and gold becomes more defined in its resting place. When the vessel is still, the suspense peaks. The surface is skimmed, removing floating silicates, organics, and foam. Beneath lies clearer water, and at the bottom, a gathering of dense material. It may not look golden at first. Black sands, magnetic iron, and other heavies often cloak the treasure, but within that dark bed lie the particles of gold waiting for their reveal. At this stage, the process repeats. The material can be decanted and reintroduced into boiling water again. Each cycle sharpens the separation, stripping away unwanted companions until only the heaviest remain. Boiling and cooling act like nature's heartbeat, contracting and releasing. Each pulse driving the gold closer to purity. What follows is the final unveiling. The concentrate is carefully poured, leaving behind the densest fraction. Sometimes it glitters immediately, tiny yellow specks gleaming among darker grains. Sometimes it hides, demanding panning or gentle blowing to uncover. Either way, the moment of recognition carries the thrill of discovery. You began with rough ore, and through nothing but fire, water, and natural traps that quietly collect gold patience, the gold has shown itself. This method, while simple, carries a deep scientific truth. Gold resists chemical alteration, refuses to corrode, and clings to density as its greatest ally. By using boiling and cooling, you're harnessing physics itself. The contrast between density, temperature, and motion. You're not forcing the gold out. You're letting it choose its place, and its place is always at the bottom. And so, the cycle continues. Each attempt brings refinement. Each batch of ore reveals its secrets slowly. Some yields are modest, flecks barely visible. Others shock you with their richness. Clusters shining like starlight trapped in stone. But always the process is the same. Fire, water, time, and trust. In the end, what begins as a suspension of dust becomes an undeniable truth. Gold is stubborn, but it cannot hide forever. Through boiling and cooling, the metal's ancient resilience becomes its undoing. And what was once locked in rock rests in your hands, gleaming with quiet defiance against the centuries that tried to bury it. This is gold recovery at its most elemental. No laboratories, no poisons, no machines, just the raw forces of nature replicated by human hands. The method is slow, but the reward lies not only in the metal itself, but in the timeless connection between Earth's hidden treasures and those patient enough to uncover them. And when the final particles are gathered, shimmering in the pan, you understand what few ever will, that even the simplest forces, boiling and cooling, hold the power to unlock the eternal brilliance of gold. And so from fire to water, from boiling chaos to cooling stillness, the story of gold unfolds once again. A story as old as the earth itself, music, revealed through nothing more than patience and the simplest forces of nature. What began as ordinary rock has now left behind, music, its shining truth. But remember, this is only one path among many. Gold is never easy, and the earth never gives up its secrets without a test. Every method has its challenges. Music, every rock holds its mystery. And every attempt pushes you closer to unlocking the treasure beneath your feet. If today's journey kept you at the edge of curiosity, imagine what waits in the stories yet untold. Here on EGS Pro, we don't just talk about gold. We reveal the hidden science, the music, ancient secrets, and the overlooked methods that nature itself designed. So, if you're ready for the next mystery, don't just leave quietly. Stay, music, with us. Subscribe, share this journey with others, and let your curiosity grow brighter than the shine of gold, music, itself. This was today's chapter, but the earth holds countless more. Until next time, stay curious, stay determined, and remember, where there are rocks, there may be gold. Most people think gold is found by luck. A pan in the water, a shiny flake at the right moment, a story passed down about a river that once paid well. But professional geologists know something very different. Gold does not appear randomly. It follows rules. It obeys structure. And long before a single nugget is pulled from the ground, its location is already hinted at on a geological map. A geological map is not just color paper. To an untrained eye, it looks like an abstract painting of reds, greens, yellows, and lines that mean nothing. But to someone who understands how Earth forms metals, that map quietly predicts where gold can exist, where it cannot exist, music, and where it almost certainly does exist, even if no one has found it yet. Gold is not scattered evenly through the crust. It is concentrated by heat, music, pressure, chemistry, and time. And every one of those forces leaves behind evidence. That evidence is recorded layer by layer, fault by fault, intrusion by intrusion. Geological maps are not guesses. They are records of ancient processes that move gold from deep magma chambers into fractures, veins, and eventually into rivers and soils. To understand how a geological map predicts gold, you must first understand one simple truth. Gold rarely forms where it is found. It forms, music, deep, often miles underground, carried by hot fluids released from cooling magma or metamorphic reactions. These fluids move upward through cracks in the crust, dissolving metals like gold, silver, and copper. When conditions change, when temperature drops or chemistry shifts, gold falls out of solution and locks itself into rock. This means gold is not just about rock type. It is about pathways. Geological maps reveal those pathways. When geologists search for gold, they are not asking where is the gold. They are asking where could gold have traveled and where would it have stopped. Fault lines on a map are not just breaks in rock. They are highways. Ancient fractures allowed mineral-rich fluids to rise. The longer a fault was active, the more opportunity gold had to move through it. On a geological map, these faults appear as thin lines, often ignored by amateurs. But when multiple faults intersect, especially near certain rock types, those intersections become prime targets. Then there are intrusive rocks. Granite, diorite, tonalite. These are not just names. They are fingerprints of magma that once rose from deep within the earth. Many of the world's richest gold deposits are genetically linked to intrusive bodies. Not because gold is in the granite itself, but because the intrusion supplied the heat and fluids needed to mobilize gold. On a geological map, intrusive bodies often appear as large, irregular shapes cutting across older rocks. Where these intrusions meet surrounding rocks, especially reactive ones like limestone or certain metamorphic units, gold deposition becomes far more likely. These contact zones are some of the most productive gold environments on Earth. But gold does not stop there. Over millions of years, erosion takes over. Mountains wear down. Veins break apart. Gold, being heavy and chemically stable, survives the journey. It moves downhill, grain by grain, flake by flake, until it reaches rivers. This is where geological maps continue to matter. Rivers that cross gold-bearing bedrock are fundamentally different from rivers that do not. A map can show which drainage systems cut through favorable geology. If a river never touches the right rock types or structures upstream, it will never carry gold, no matter how beautiful it looks. Professional prospectors do not pan random rivers. They trace watersheds backward on geological maps. They follow streams uphill until they intersect fault zones, intrusive contacts, or metamorphic belts known to host gold. Only then does fieldwork begin. One of the most powerful yet overlooked elements on a geological map is rock age. Gold deposition is not equally likely in all geologic periods. Certain eras were far more productive due to global tectonic conditions. Greenstone belts, for example, are ancient volcanic sedimentary sequences that, music, formed billions of years ago. They are responsible for some of the largest gold camps on Earth. On a map, greenstone belts stand out clearly once you know what to look for. They often appear as elongated zones of metamorphosis, volcanic rock surrounded by granitic terrain. These belts host shear zones, another key gold indicator. Shear zones are areas where rocks have been intensely deformed, creating endless microruptures that, music, trap gold-bearing fluids. The map does not say gold here in words. It says it in patterns. Another critical element is alteration. Gold rarely travels alone. It is accompanied by chemical changes in the surrounding rock. Silication, iron staining, carbonate alteration, and sulfide minerals all leave signatures that geologists can recognize. Geological maps often include alteration zones or are paired with geochemical overlays that highlight these changes. When alteration halos align with structural features in favorable rock units, the probability of gold increases dramatically. This is how professionals narrow down vast regions into specific targets. And then there is scale. Large-scale maps show regional trends, belts, and terrains. Small-scale maps reveal individual faults, veins, and contacts. Gold exploration always begins large and moves small. The map tells you where not to waste time. What makes this approach so powerful is that it removes guesswork. You are no longer searching blindly. You are testing a hypothesis built on Earth's own history. This is why experienced geologists can walk into unfamiliar terrain and identify gold potential within hours, sometimes minutes. They read the landscape the same way a doctor reads an X-ray. The hills, the rock colors, the stream directions, and the fractures all confirm what the map already suggested. Even modern gold discoveries still rely on these principles. Satellites, geophysics, and drilling all start with geological interpretation. Without the map, none of the advanced tools know where to look. And perhaps the most important realization is this: geological maps do not become obsolete. Gold does not move back uphill. The processes that form deposits ended millions of years ago, the clues remain fixed in stone. Which means that even today, with the right understanding, the map can still lead you to gold that has never been touched. And this is where most people make a critical mistake. They look at the map but do not know what combinations matter. They focus on a single feature instead of convergence. Gold almost never forms from one factor alone. It requires alignment. Rock type, structure, heat source, fluid pathway, and timing must all intersect. When three specific geological elements appear together on a map, professionals pay attention because history has shown that when those three align, gold is rarely far away. And once you know how to recognize that combination, you stop searching randomly and start predicting where gold must be. The map stops being a reference and becomes a forecast. And that is where the story continues. When geologists talk about alignment, they are not speaking in vague terms. They are referring to a specific convergence that has repeated itself across continents, across ages, and across nearly every major gold province ever documented. It is a pattern so reliable that when it appears on a geological map, attention shifts immediately. Budgets move, drill rigs follow, and history shows that gold often follows, too. The first element in this convergence is a competent host rock, usually one that can fracture without collapsing. Quartz-rich rocks, metamorphosed volcanics, and certain intrusive margins excel at this. These rocks do not absorb stress quietly. They crack, and cracks are everything. Without fractures, gold-bearing fluids have nowhere to travel, music, and nowhere to settle. On a map, these rocks appear as continuous units that persist over distance, not scattered patches. Their continuity matters because gold systems need space to develop. The second element is a structural engine. Faults, shear zones, fold hinges, music, and deep crustal breaks are not just accidents of geology. They are the plumbing system of the planet. These structures move heat, pressure, music, and fluid over immense distances. A geological map reveals their geometry, their orientation, and often their relative age. Gold favors long-lived structures, ones that were reactivated again and again over geological time. Each reactivation is another opportunity for gold to move and redeposit. Where these structures cut through the right host rock, the probability of mineralization increases sharply. But this alone is still not enough. Many regions have good rocks and strong faults and still contain no gold. That is because a third element must be present. The third element is a thermal or chemical driver. This is usually represented on a map by intrusive bodies, metamorphic gradients, or specific rock assemblages that indicate deep heat sources. Gold does not mobilize in cold systems. It requires energy. Magma rising from depth or rocks undergoing intense metamorphism release fluids capable of dissolving and transporting gold. These fluids are the carriers. Without them, gold remains locked and invisible. When these three elements overlap on a geological map, a very specific picture forms. A fracture-capable host rock, a major structure that can move fluids, and a heat source that can load those fluids with gold. This is the three-rock in a structure convergence, music, that professionals quietly look for. What makes this approach powerful is that music, works before any gold is ever seen. It works even in places with no mining history. It works in forests, deserts, mountains, and private land where prospectors have never set foot. The map tells a story. long before the ground does. Music, once this convergence is identified on a regional map, geologists, narrow the focus. They move to more detailed maps, looking for secondary structures, bends and faults, changes in rock competency, and zones of alteration. Gold rarely deposits evenly along a structure. It prefers traps, places where pressure drops suddenly, where fractures widen, where chemistry shifts just enough for gold to fall out of solution. On the ground, these traps often appear subtle. A slight bend in a ridge, a change in rock color, a line of iron staining that follows no obvious pattern to the casual observer. But to someone who has already read the map, these features confirm what was predicted. Even placer gold follows this logic. Rivers do not create gold. They inherit it. When a drainage cuts through terrain where this three-element convergence exists upstream, gold enters the system. From there, physics takes over. Gold settles where energy drops behind boulders, inside bedrock cracks. On the inside bends of rivers where flow slows and heavy material drops out. This means geological maps can predict placer gold just as effectively as hard rock deposits. By tracing river systems backward into favorable bedrock and structure, geologists can identify streams that must contain gold, even if only fine flakes. Conversely, rivers draining barren geology can be eliminated instantly, saving years of wasted effort. Modern technology has not replaced this thinking, it has amplified it. Remote sensing, geochemistry, and geophysics all layer on top of geological interpretation. But none of them function intelligently without it. The map remains the foundation. This is why the highest value gold discoveries are rarely accidental. They are the result of disciplined interpretation of understanding how Earth behaves when pressure builds, when rocks break, and when fluids move. For those willing to learn this language, gold stops being a mystery and becomes a probability problem. You are no longer asking if gold might be present. You are assessing how likely it is and where it must have gone. And this changes everything. It changes where you walk, where you sample, where you pan, where you drill, and just as importantly, where you do not. The geological map does not promise gold, but when read correctly, it quietly removes most of the uncertainty. It narrows the world down to places that make sense. And when that three-element convergence appears clearly on the map, history suggests that gold is not far away, often closer than anyone expects. Gold is rarely random. It follows structure, pressure, heat, and time. What appears to be empty land often carries a history written deep, below the surface, waiting to be interpreted. Geological maps do not guarantee discovery, but they quietly reduce chance and replace it with understanding. When you learn to read the signals the Earth leaves behind, every ridge, every river, and every rock formation begins to speak. And in that language, gold has always left clues for those trained to listen.